Hi, this is the Masking Handbook for Audiometry. We're looking at crossover, cross-hearing, and the need for masking. During audiometry, we try and test each ear individually. If we take a speaker and install it in the ceiling and present a sound, it's impossible for us to know which ear has heard the sound. Let's say we have a test subject who has really great hearing in one ear and no hearing at all in the other. Let's take this person and seat them in a room. We'll present sounds through the ceiling speaker. The person would respond even if we presented very soft sounds, but we wouldn't be able to know which ear was hearing the sounds and which ear was the non-hearing ear. This is the reason why we use earphones. We place an earphone on an individual ear and deliver test signals specifically to that ear. In theory, when a person responds to a test signal using this method, we'll be able to know which ear has heard it. However, even when using air conduction devices like earphones, we must be aware that sound signals sometimes don't remain with the ear into which we're delivering the signals. It's possible for air conduction sound to travel away from our targeted test ear and move to the opposite side. Once test signals reach a moderately loud level, it's possible that they'll enter the bone tissues of the head. Once they're into the cranial bones, then they can cross to the other side. This can happen with both TDH-style supraoral headphones and also our insert earphones. We try to deliver sounds into a specific ear. The typical route is for the sound to travel through the outer ear and middle ear pathway where they'd reach the cochlea of our test ear. Sometimes the signals can enter the bone tissues to get to our test ear cochlea, but once this happens, the signals may also cross to the opposite ear's cochlea as well. Let's look at a situation where we're trying to complete air conduction testing on a right ear. The left ear is our non-test ear. Using TDH headphones, we deliver a 50 dB HL pure tone signal into the right ear. Anytime we're presenting a test signal to a test ear, we should observe the various dynamics at play. The first item is the dB level of the test signal itself, in this case 50 dB. We must also be aware of the amount of sound that is possible to remain on the test ear side. There's a limit to the amount of sound that will remain. We should also be aware of the amount of sound that is possible to cross over to the non-test ear side. The amount of sound that is blocked to the test ear side, the amount of sound that is prevented from crossing to the non-test ear side, is called our attenuation value. We refer to this as our interaural attenuation. The amount of sound that might be possible to cross to the opposite side is our potential crossover value. If we have an interaural attenuation value of 40 dB, we can figure out what the potential crossover value will be. With this IA value and a test signal level of 50 dB, we conclude that it's possible there may be 10 dB of potential crossover to the left non-test ear side. Whether or not this 10 dB amount of crossover will affect or bother the left non-test ear depends on the cochlear hearing of the left ear. The cochlear hearing is reflected in the bone conduction hearing on that non-test ear side. If the bone conduction thresholds of the left ear are all 70 dB, then 10 dB of crossover will not affect it. If the bone conduction hearing of the left ear is minus 5 dB, then a 10 dB crossed sound will likely be heard on that left side, and we refer to this as cross hearing. We're looking at results of a survey on interaural attenuation from various research papers that looked at the issue for TDH-style headphones. Let's take a look at 500 Hz. First, we see that the mean median values fall somewhere between 50 and 60 dB. So that's kind of an average amount of interaural attenuation for those headphones when we're delivering 500 Hz pure tone signals. The maximum amount of attenuation documented is 75 dB. The minimum possible interaural attenuation found using these headphones for 500 Hz is 40 dB. So we know that 40 dB is the minimum possible amount of attenuation that we know of for this test tone using these headphones. So when we're testing someone at 500 Hz using TDH headphones, the possible interaural attenuation situation could fall within this wide range between 40 and 75 dB. We won't know the individual attenuation value for a specific person, but it'll probably fall within this range. But when we're making decisions on audiometry, we must use the minimum possible values, or the least amount of possible attenuation. We refer to this as the min-IA level. And this is the level at which we know it's possible that a 500 Hz tone could cross to the other side. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.